Good morning all. Now I would like to explain about AC voltage is given to pure inductor. Okay. Now see here, let us consider a inductor having a inductance of L. Okay. AC voltage is given to this pure inductor, right? Then already we know that the voltage across the inductor formula is VL is equals to L into di by dt. Okay. Then current flowing through the inductor is I is equals to Im sin omega t. Okay. Then voltage across the inductor will be L is equals to d by dt of, already we know I value, right? That is Im sin omega t, right? That is L into, here Im is constant, d by dt of sin omega t value will be cos omega t into omega, right? Then voltage across the inductor is L into Im into cos omega t into omega. Okay. After that, voltage across the inductor will be L into omega into Im into cos omega t, right? Then this value can be written as omega L into Im into cos omega t can be written as sin of omega t plus 90. This plus 90 degrees is represented by J operator. In mathematics we have a I operator that indicates 1 at an angle 90 degrees, but in electrical terminology already I is indicated by current, right? For that purpose here this I operator is represented by J in electrical circuits. Okay, this J operator indicates 1 at an angle 90 degrees. That means this 90 degrees is represented by plus J operator. That is voltage across the inductor is plus J into omega L into Im sin omega t. Im sin omega t is nothing but already we know I value, right? That is voltage across the inductor VL is equals to plus J into I into omega L. Okay, where omega, from this equation voltage across the inductor is equals to plus J into omega L is nothing but XL into I, where XL is equals to inductive reactance, that is equals to omega L, that is equals to 2 pi FL. Okay, now see here, from this result this plus J operator indicates plus 90 degrees, right? That means from this result voltage leads current by 90 degrees, or current lags voltage by 90 degrees in case of pure inductor. Already we know in case of pure resistor voltage and current both are in phase, right? There is no phase angle difference between voltage and current, whereas in case of inductor voltage leads current by 90 degrees or current lags voltage by 90 degrees. Now if I draw the phasor diagram, here current is taken as reference here. Okay, that means here voltage leads current by 90 degrees, or if I take current is taken as reference here, this is minus 90, right? That means voltage starts at 0 degrees. That means voltage leads current by 90 degrees. Okay, we can draw the phasor diagram in our wish. Okay, after that, if I represent this equation, this waveform, this phasor diagram in waveformatically, okay, see here, this is the voltage waveform. Okay, already we know this half cycle will be 180 degrees, right? From center of this half cycle 90 degrees, right? Okay, that means after 90 degrees current is started, right? That means voltage leads current by 90 degrees, or current lags voltage by 90 degrees in case of pure inductor. That means the cosine of angle between voltage and current is nothing but power factor, right? Where phi is here angle between voltage and current. Now see here, the phi value will be 90, cos 90 value will be 0. That means in case of pure inductor power factor is 0. Okay, next, instantaneous power. Already we know that power equation is power P is equals to V into I, right? Instantaneous value of voltage is Vm sin omega t. Okay, after 90 degrees only current is started, right? Then current I is equals to Im sin omega t minus 90. That is instantaneous power P is equals to Vm sin omega t into Im sin omega t minus 90 can be written as minus of 90 minus omega t. Okay, sin of minus theta will be minus sin theta, right? Then average power P is equals to minus Vm Im sin omega t into cos omega t. Okay, if I multiply and divided by 2, I will get minus Vm Im by 2 sin omega t into cos omega t. That is instantaneous power P is equals to minus Vm Im by 2 into sin 2 omega t. Okay, then average power over a complete cycle. This complete cycle is having 2 pi seconds time period, right? then average power is equals to 1 by t. T value will be 2 pi, integration 0 to 2 pi minus Vm Im by 2 sine 2 omega t into d omega t. Okay, if I simplify this equation, here I can take 2 is outside, right? This value will be here, Vm Im will be constant, right? That is minus Vm Im by 4 pi, integration of sine 2 omega t will be minus cos 2 omega t by 2, right? Substitute upper limit and lower limit, then here the resultant value will be minus Vm Im by 4 pi, substitute upper limit, minus cos 4 pi by 2, minus of minus plus cos 2 into 0 by 2, right? This value will be 0, then average power is 0, right? In case of inductor, average power is 0. Okay, I will show you waveformatically. Okay, I will draw once again here. Just observe the waveform. This is the voltage waveform, right? After 90 degrees current waveform is started. I can extend this waveform like this, right? Now see here, this waveform is divided into, for full cycle, this waveform is divided into 4 equal parts, right? 1, 2, 3, 4. Okay, this is pi by 2, pi, 3 pi by 2, right? And here 2 pi, 90, 180, 270, 360, right? Now see here, power is nothing but product of voltage into current, right? For this period from 0 to pi by 2, voltage is positive. This is the voltage waveform, right? And this is the current waveform, right? Voltage is positive and current is negative. Plus into minus, minus, right? We will get power like this. Okay. Magnitude will be increased as product of voltage into current. Okay. Similar way, from pi by 2 to pi, voltage and current both are positive, plus into plus, plus, right? Then power will be again in positive of cycle. Again from pi to 3 pi by 2, current is positive, voltage is negative, plus into minus, minus, right? Again current is negative, voltage is also negative, minus into minus, plus, right? This will be repeated. Now observe the waveform here. With respect to time, here the magnitude of voltage and current on y-axis, right? This is the voltage waveform, right? This is the current waveform. Okay, now see here, for over a complete full cycle or over a half cycle, average power will be 0. Why? Because see here, this is the power magnitude in negative direction, this is the magnitude of power in positive direction, right? For example, plus 50 watts, minus 50 watts plus 50 watts, cancel each other, minus 50 watts plus 50, minus 50 plus 50, right? Then average value will be 0. This is the representation waveformatically. Okay, thank you all.